In the beginning, there was nothing, but then, suddenly, there was everything. For thousands of years, people have tried to find the origin of our universe, primarily through the notion of God. But this explanation only needs cold, hard science. No God. Go back far enough in time and the universe is so hot and dense that stable atoms can't form. Even further, those atoms break apart. Even further, and those protons and neutrons degenerate into a quark-gluon soup. And before that, all four fundamental forces were united into one grand unified force. Go back even further than that, and the notion of time itself begins to fall apart. This is the Big Bang Maxplained. If our universe is expanding, you can extrapolate backwards and determine that at one point in the finite past, our universe must have been infinitely small and dense. Before the beginning of time, all of the mass and energy of the universe was confined in an infinitely dense point called a singularity. But then, quantum fluctuations caused it to rapidly expand. The first era of the Big Bang was the Planck era, lasting before the elapsed time was equal to Planck time, or 10 to the negative 42 seconds. At time so inconceivably short like this, the very notion of time itself begins to break down as quantum mechanics begin to take over. We don't really even know if before is an appropriate term for what happened during the Planck era. Space and time don't make any sense, and our current model of physics can't explain it. So for all intents and purposes, this is the beginning of time. Even gravity itself had yet to become its own thing. Gravity then proceeded to come into its own, and the electromagnetic and the strong and weak nuclear forces were all one grand unified force. At a high enough energy, these three forces become united into one. Oh yeah, did I mention it's like really hot? Like 180 nonillion degrees Fahrenheit? That's 180, followed by 30 zeros. That's really hot. The first elementary particles also began appearing about this time. But at this point, stuff like mass, charge, flavor charge is not a thing. Stuff like mass, charge, flavor, color charge was all meaningless. Something, however, that we can't explain, though, is why there's far more matter than antimatter in our universe. Logic and our predictions would suggest that equal amounts of matter and antimatter should have been created during the Big Bang. But if that was the case, the universe would have immediately annihilated itself. Then the strong nuclear interaction, which is the interaction that holds atomic nuclei together, became a thing, and led the way for inflation. Basically, the universe is all of a sudden, like, really big now. And it's filled uniformly with a quark-gluon soup created by the release of inflationary potential energy. Normally, gluons bind quarks into protons and neutrons, but the universe is so hot, energetic, and dense that atoms break down into this state. There was once a time where the universe was the size of this apple, or an orange, or a small grape. Really, the fruit doesn't matter here. Where all of existence was able to fit in the palm of your hand. The entirety of the Milky Way could have been crammed into the volume of a single hydrogen atom. I'm eating the universe. Then the universe cooled off to a nice, balmy 180 billion degrees Fahrenheit. Then all sorts of cool particles like W and Z and Higgs bosons began to appear, and then they disappeared, and then all the quarks decided to form hadrons. Now there's hadrons, neutrons, no atoms though. It's still way too hot for that. Oh yeah, I should mention that the age of the universe right now is 1 second. Yeah, all of that happened in 1 second. And now leptons showed up to the party and dominated the universe's mass for a good 10 seconds while atoms began to form. The first elements, hydrogen, helium, and lithium, all appeared during this time. But some of those leptons developed huge crushes on the atoms and tried to bond with them. But it was too hot to do so, and that's the way things would be for 380,000 years until the universe began to cool off and settle down. This allowed the electrons to bind to the atoms. Until this point, the entire universe was filled with an opaque hydrogen plasma. And then things went dark for about a few 100 million years. And then, stars, galaxies, black holes, oh my! Some of those stars explode, creating new elements in the process. Then one day, around 9 billion years after the Big Bang, dark matter and dark energy seize control of the universe and its expansion begins to accelerate. Around the same time, a very special star and a very special planet begin to form. And on this very special planet, non-living organic compounds become an actual living organism, and then for the next 4 billion years, they evolve, becoming an increasingly complex and intelligent. They almost all died a couple times, but they pulled through. One of these organisms eventually began putting the entire planet to their use, and here we are. That was the Big Bang Maxplained. Thank you all so much for watching. If you enjoyed, feel free to like and subscribe. It's always appreciated. And yeah, this is gonna be the start of a new series called Maxplaining. It's a pun on mansplaining if you didn't know. And also, yeah, I'm bringing back the old outro music, if you can hear it. I haven't used this since like 2017. That's all for now. Thanks for watching. I'll see you all later. Bye-bye.